So as I mentioned, each port on the switch is considered to be in its own collision domain, which means we can have full duplex communication, we can send traffic, and we can receive traffic at the same time. Where before, with the half duplex communication, you had to listen before you sent, which means you're using the same cable to send traffic and to receive traffic. So the switch is separating each of the ports into their own collision domain. They can run in full duplex mode. We should see that the switch and the routers would automatically figure this out when we look at the show interfaces status on the switch. Show interface status is going to show us a bunch of information about the ports that are connected. Here, this name field, this could be a description that we put on there. Like I say on Fast Ethernet 1, the description is 2R1. And this is one way that we can do some basic documentation on the network. So now I know where that port goes. So I could say it goes to my web server, or goes to whatever this host address is. So this port that's connected to router 1, it automatically figured out that it should be running in full duplex mode, and the speed is 100 megabits per second. So since the switch is separating each of these ports into their own collision domains, then we can run in full duplex mode, which means we're using one set of cables for sending traffic and another set of cables for receiving traffic. So each port's in its own collision domain, but still by default, all of the ports are going to share what's known as the broadcast domain. Where again, the broadcast domain means that if I send a packet that goes to the layer 2 address, all Fs, everyone in the same broadcast domain should be able to receive this. So this is how, like in the case of Windows, if you were to go to your network connections, and let's say I'm not sure how you do this on here. My network places, there we go. The entire network. Microsoft Windows Network. So let's say here I'm trying to find what are other Windows machines that are on my same LAN. What Windows is doing behind the scene is sending layer 2 Ethernet frames that are going to that all Fs address, trying to discover all of the hosts that are on that same network. So this is the same thing like that Mac OS uses with its Bonjour service, like to find printers and to find other devices. That it's sending these frames that go to all Fs. Anyone that's in the same broadcast domain is going to be able to hear these. Now, the disadvantage of this is that if the broadcast domain is really big, it can start to slow down the network. That if everyone is using this Windows browsing service and the Linux and the Mac OS browsing service, you end up getting a lot of traffic that you don't actually need. And it takes CPU cycles on the machine to actually process those packets. And then it also takes bandwidth on the physical link in order to send and receive those. So as the network starts to grow, this is one of the disadvantages. And the solution to this is that we can group ports together in what is known as a virtual LAN, or a VLAN. Where the idea is that we don't want to have to buy separate switches for one portion of the network versus another one. I want to just be able to plug everyone into the switches that are all connected together, and then I could make separate virtual or logical separations of the network. And that's ultimately what the VLAN is doing here, is that it's breaking the ports down into different sets of broadcast domains. So ports that are going to share the same VLAN number are in the same broadcast domain. Normally, you'll see that the VLAN also maps one-to-one with an IP subnet. So if I were to say that I had VLAN 100, maybe this corresponds to the IP subnet 192.168.100.0/24, where VLAN 101 corresponds to 192.168.101. Now, technically, these numbers are unrelated. You could set the IP addressing to be whatever you want. You could set the VLAN number to whatever you want. But a lot of times, they will have some relationship to each other to make the documentation of the network a little bit easier to understand. So if I know that my subnet is 101 here, if I always name my VLAN number the same thing, it makes it a little bit easier to troubleshoot if there's a problem in the Ethernet switches. Now when we get to routing, we'll see that one of the changes that's going to happen is that since devices in VLAN 100 are now in a separate broadcast domain than devices in VLAN 101, we're going to need someone to allow us to do this communication. That if someone on the address 192.168.100.1 wants to send a packet to 192.168.101.1, that the packet, since they're on different layer 3 subnets, the traffic is going to have to be routed between them. And that's what the layer 3 IP router is doing. So it's typically going to run layer 2 protocols as well, like Ethernet or other WAN protocols. But the goal of the routing is to get the traffic between different subnets. Because the subnets are corresponding to these broadcast domains, and there's no way for a host in VLAN 100 to directly talk to one that's in VLAN 101. So the key is that the ports in the different VLANs, these are going to be in different broadcast domains. So let's look at this in our current configuration. Where let's say now in this network we want to make a couple different logical groupings. Where I want these 3 devices to be in the same VLAN. We'll say these are going to be in VLAN 100. And router 3, router 5, and router 4, I'm going to put these in a different VLAN. I'm going to put these in VLAN 101. Now, the thing that's nice about the VLANs, it makes it very flexible, is that it can span multiple physical switches. So even though router 3 and router 5 are physically connected to different switches, we can still communicate this VLAN information between the links that are connecting the switches. And this is what we consider as a VLAN trunk. Now, a VLAN trunk is basically when we assign a single interface to run multiple VLAN numbers at the same time, because we're trying to span the virtual LANs between multiple physical devices. So it's essentially just a port that runs multiple VLANs at the same time. And the way that this is accomplished is that when we build the layer 2 Ethernet frame, the switches are going to put the number of the VLAN as an additional field. So when they receive the packets, they know which virtual LAN that it's corresponding to. So in this example, switch 3 and switch 2, when they exchange traffic from router 5 going to router 4, inside the Ethernet header, they're going to put number 101 in there. So we have the normal Ethernet header plus this number 101, and then we have whatever our IP packets are inside there. Maybe this is an ICMP ping, or it's like a web browsing packet. But the key is that as long as the switches agree on what these numbers are, the broadcast domains can span between multiple physical devices. So the first step then would be to tell the switches what are the numbers that we're going to use. The way that we do this on the actual command line is in global configuration, we use the VLAN command and then specify the numbers that we want to create. So here I want to create VLAN 100. I want to create VLAN 101. If we then look at the show VLAN, it's going to show what are the current numbers that are being used. Now, right now, these switches, they actually have a couple other VLANs in here from before. What I'm going to do for right now is to remove these. And let me double check one thing before I do this. That is, okay. So So first I'm going to delete the other VLANs that were in here. And I'll explain a little bit exactly why I need to do that. So let's say no VLAN 100 to 110 were the other numbers. Then we'll look at the show VLAN output. Normally what you would see here is that the switch is going to have 5 VLANs by default. Where VLAN 1, this is what all of the ports belong to automatically. This is our default Ethernet VLAN. These other ones, 1002, 1003, 1004, 1005, these are for other legacy protocols that we don't run anymore, like FDDI and Token Ring. So these ones, from our perspective, they're not going to be used for anything. They're just defaults that are for older legacy network support. But we essentially have this range from 1 to 1001 that we could then define for new broadcast domains. Where if I have 10 subnets in my network and I want to connect them between different switches, I could define 10 different VLANs. And as long as the VLAN corresponds to that particular subnet, so I actually tell that port that it's going to be using that VLAN number, hosts in that same subnet should be able to communicate with each other. So again, I'm going to create these VLANs. I'll say VLAN 100 and VLAN 101. When we look at the show VLAN, I should now see these two new numbers, VLAN 100, VLAN 101. They're not actually assigned to any interfaces yet, so no one is using them. You could also put a description here where the name of the VLAN by default is VLAN and then the number, where a lot of times you'll see things like for VLAN 100, maybe the name of this is for accounting. Or for VLAN 101, the name of this is sales. So when we look at the configuration of the network and look at show VLAN, I know that anyone who's in the sales department, I want to put them in VLAN 101. But this is just for your own documentation purposes. It doesn't really affect anything in the traffic. So now the other switches, they would want to agree on this. I want VLAN 100 and VLAN 101 on all 3 of the switches, VLAN 100, VLAN 101. Again, if we show VLAN, we should see that the switch knows about this, but it's not actually assigned to anything. And we'll see, I'll talk about this in a couple minutes here, but there's a protocol that the switches try to run automatically to exchange this information with each other. So when I created the VLAN on switch 1, it actually told the other 2 switches about it. So you don't have to manually keep creating it over and over and over. But we'll look at the details of that in a second. But the key is that at least all 3 of them agree that there's now 2 different VLANs. There's VLAN 100, there's VLAN 101. Next thing that we would do is assign them to different interfaces. Where on switch 1, I'll say that ports Fast Ethernet 1 and Fast Ethernet 0/24, their VLAN membership is going to be 100. And the way that we do this at the interface level, interface Fast Ethernet 0/1 here connects to router 1. I would say the switch port access VLAN is whatever number I defined. So this VLAN number is going to be 100. Where an access port, in the terms of switching, means that it connects to one end host. So an access switch port would go to your laptop or would go to your IP phone or like to a printer, where the links between the switches, these are the trunk ports. So a trunk port is going to be for carrying multiple VLANs. I want to run VLAN 100 and VLAN 101 on this link. But for the link that goes to router 4, it only needs one assignment. So it's an access port, and that access port is going to have VLAN 101 as its membership. So let's do the other assignments now. So port 24 that's going to the Windows machine. This likewise is going to be in switch port access VLAN 100. The port that goes to router 3, this is going to be in 101. So let me clean up the diagram a little bit here.
Is that trunk line exclusive with the VLAN memberships? I mean, would that not carry any traffic outside of VLAN? In other words, if there's traffic that is not under VLAN 100 or 101, is FA 016 going to carry that between switch 2 and 3?
It will by default.
Okay.
You can tell it not to, but normally the trunks are going to carry all of the VLANs.
Okay. So adding the memberships to that, 100 and 101 does not exclude other traffic.
Correct. Correct. It doesn't exclude other traffic. So these two ports, these are going to be in 100. This one here is going to be in 100. And the second assignment is going to be 101. So on switch 1, then this other port is fast Ethernet 0/3. Switch port access VLAN 101. And if we now look at the show VLAN, it's going to tell us what interfaces are now members of that VLAN or of that broadcast domain. So for VLAN 100, which I named accounting, it's now for ports fast Ethernet 1 and fast Ethernet 0/24. VLAN 101, this corresponds to fast Ethernet 0/3. We'll see that the result of this is that the switch is now going to keep multiple copies of the MAC address table or multiple copies of the CAM table, where there's a separate table for VLAN 100 than VLAN 101. Because the devices in VLAN 100, they can't directly talk to the other ones. So you could also think of this as like a layer 2 security feature, that if the ports are not in the same VLAN, they're not automatically going to be able to talk to each other. We can see this if we now go to the Windows machine. And previously, we were able to ping any of these destinations. We were able to ping router 4 and router 2. But if I try this again, if I ping 192.168.0.1, I'm able to reach router 1 because we're in the same VLAN. But anybody else is now in a different VLAN number. They're in a different broadcast domain. So when I'm sending my ARP packets, the address resolution protocol request, I send the request out, but I'm not getting a response because my Ethernet frame can't go to the port that's assigned to this user or assigned to that end machine. So this is one good test of the VLAN assignments. If you can ping the devices that are in your same VLAN, it most likely means that you have the correct VLAN assignments. So let's do the rest of them now. Let's go to switch 2. And on switch 2, we'll say the link that goes to router 2. The switch port access VLAN is 101. On the port to router 4, this is VLAN 100. Then on switch 3, the port that's going to router 5 is switch port access VLAN 101. Again, we can see the assignment when we look at the show VLAN. It says VLAN 101 is assigned on that port, fast Ethernet 0/5. And if we look at the show interfaces status, show interfaces status is a good way to quickly view what are the different interfaces doing. So by default, everything is in VLAN 1. This one I manually changed it so it was in 101. Then the links between the switches, these are automatically configured as trunks. And we'll talk about in a little bit exactly why that's happening. But the switches essentially figured out that this port goes to another switch, so I probably want to send more than one VLAN to them. So now let's test the result of this. If the Windows machine in VLAN 100 is in the same IP subnet as router 4, and it's in the same VLAN, we should be able to ping from the Windows machine and reach router 1, and we should be able to reach router 4. But we shouldn't be able to get to 3 because 3 is in now a different virtual LAN. It's in a different broadcast domain. So if we ping 192.168.0.1, we see we're able to reach router 1. We're able to reach 4, but we shouldn't be able to reach 3, nor could we get to 2 or to 5. It also means those addresses I had assigned on the switches, I can't reach those anymore either, because these addresses were assigned to what?
VLAN 1.
Those were assigned to VLAN 1. So the switch can run IP as well. We'll look at some cases later when it's not only running layer 2 Ethernet switching, but it can run layer 3 IP routing. So it can do both functions at the same time. And this is the reason why we can create these different VLAN interfaces, where typically this is the address that the hosts are going to use as their default gateway. So if I have ports that are in VLAN 1, and for me to reach other subnets, I want to go to this switch. On the Windows machine, I would point the default gateway to 192.168.0.6. But we'll talk about that more when we get to routing. So now let's verify the other one. I should now be able to see that for the other VLAN, for 101, I should be able to talk to 3, 5, and 2. Two should be able to talk to 3 and to 5. If we look at the show ARP, we see that we know about what their MAC addresses are. If I were to try to ping router 1, we'll see that these packets are not going to get through. Then if we look at the show ARP again, we have what's known as an incomplete entry. Basically, this means that router 2 tried to figure out what the MAC address is of router 1, but it didn't get a response back in. Because the destination address it used, that all Fs, these frames can only go between ports that are in the same VLAN. So when we look at this from the perspective of the switches, they're now essentially going to have two different tables that are holding the MAC addresses. It's going to have a table that is for VLAN 101 that should have the MAC addresses of router 2, router 3, and router 5. Then a separate table for VLAN 100 that is for router 1, router 4, and then the Windows machine, the PC. So if we go to the switches and look at what command to see the MAC addresses. Show MAC address table. But now I may want to separate the MAC address table based on the VLAN number. So if I look at VLAN 100, this should show under the dynamic entries, these are going to be the ones that I automatically learned. These should correspond with, and let's group these together, where I had router 1, and 4, and the PC, where the PC's address we can see here if we say ipconfig/all, This is 000C 29F8 A35E. You'll see sometimes these are shown two different ways, where there's the dashes between the sets of numbers and letters. That's because each of these is 1 byte. So a MAC address is 6 bytes long. 1, 2, 3, 4, 5, 6. Where in hex, a hexadecimal digit is 4 bits. So it takes 2 of them to make 1 byte. Most of the time on the routers and switches, you'll see it listed this way, where it's sets of 2 bytes that are separated by dots. But it really means the same thing. You can look at it either way. So now I have VLAN 100 and VLAN 101. The switches, they're still in the default VLAN of 1. We then looked at the show MAC address table VLAN 100, and I'll say, to cut down on the output a little bit, we'll also say dynamic. So just the ones that I learned. These should correspond with 1, 4, and the PC, which it does. Let's see, who is this? 001E. 001E. Okay, let's try to work backwards on this. On switch, actually, never mind. This is some other host that we don't need to worry about. So let's test this connectivity again. Let's go to router 1 and ping 192.168.0.4 and 100. We can see I still have that debug running that's talking about the ARP requests. So there was an ARP packet that went between router 1 and 4 so they could figure out each other's MAC addresses. Now on the switch, it should know router 4's MAC address in the table, which it does, the 000F. Router 1's entry is there, and the PC is there. If we were to look at VLAN 101, we should see the other entries. So for router 3, 00119221, you'll see eventually these values are going to time out, where you don't automatically keep them indefinitely. If the hosts are not sending traffic between them, it gets deleted after a certain amount of time, and then you would have to relearn them. But if I were to go to router 3 now, and let's ping these other hosts. Let's ping 192.168.0.2. I'm dot 3, and then 5 I should be able to reach. Now the switch should know about all 3 of those, which it does. If we also looked at this for VLAN 1, these would be the addresses that are on those VLAN interfaces of the switches themselves. So again, typically you wouldn't have a case where you have separate VLANs that have the same subnet, where I may say that this one is 192.168.100, and say this one is 192.168.101, because the VLAN assignment is then going to control who you can reach in your own subnet or in your own IP network. So although technically the VLAN is only layer 2, normally for simplicity they have that one-to-one relationship, where the layer 2 network and the layer 3 network have that relationship.